Okay, let's go ahead and get this show on the road. I hope my audio is okay. If I'm not legible, someone please let me know. Otherwise, I'll just keep talking. My name is Adam Capriz. I'm the applications lead for Holland Computing Center. So I'll be the instructor / disembodied voice for the session today. So the idea today is to learn a little bit about how to use various applications and software on Holland resources, primarily our HPC resources, the Swan and Crane clusters. So like I said, my name is Adam. We've got, I believe, Emily, Naruktha, and Colin virtually milling about. And Natasha's here as well. So any of the folks that have HCC in front of their name are HCC staff, and they're happy to help you. I probably won't be able to keep an eye on chat the whole time, but I think my colleagues are going to do that. So if you have an issue, post it in the chat, and someone will probably message you individually to see what's going on. So let's get the slide to go to the next deck. Yep. So some links. Hopefully everybody has access to this PowerPoint and these links. So the go.unl link, that's the link to this PowerPoint. So, linkception. We're going to use for today's lesson a Conda for data scientists lesson. This is out of the Software Carpentry organization. If you're not familiar with Software Carpentry, it's a great organization. They run 2-day style boot camps for various topics. Several of our folks are certified instructors. We do some of these. We do these things as well. And so they develop different lessons for different topics. So we're going to use their Conda lesson today. I will give you a heads up that it's still in a beta status. So there may be some inconsistencies and goofs here and there. So please bear with us. But generally speaking, it's a good lesson. Also, a link for using Conda environments in Jupyter. So we'll talk about that later. But basically, if you want to create a Conda environment and then use it inside your Jupyter notebook, we'll talk about how to do that. And then also just the general workshop website, and then our documentation links and our support email. If you need help, the support email is really the best way to get a hold of us, since it goes into a ticketing system, and the best person for it can reply. So any questions from anybody before we get started? Is everyone up to speed with what we're doing today? Any other issues or questions? Looks like Colin helpfully put all the links in the chat. So thank you, Colin. And don't be afraid to unmute yourself and just talk. There's not that many of us here today, so pretty informal. It would be great if we could have more of a conversation style today, rather than just me spewing information at you for 4 hours. Okay, so what we'll talk about today, we'll talk about Open OnDemand. They covered this a little bit last week, but I'm not sure if everyone was here last week, and it doesn't hurt to go over it again. So we'll spend a little bit of time talking about Open OnDemand, which has really been a sort of a game changer for how to access HPC resources. It's a web-based thing, so everything runs in your browser, and it gives you a nice GUI interface to various things on the cluster. Lets you upload and download files. We have several dedicated applications, so if you want to run MATLAB, for example, the full GUI on the cluster, it makes it easy to do that. It has job management and monitoring built into it, so you can actually submit jobs from it. You can see what your jobs are doing. So it's a softer introduction than just having to stare at a blank, blinking, unfeeling command prompt, which is how it used to be. So if you're new to HPC resources, we generally recommend that you start with Open OnDemand, and then as you ramp up in your needs and your skills, you can transition over to the pure command line environment, which is still the most powerful way. So the command line environment isn't going anywhere anytime soon. It's a very powerful way of interacting with the clusters or any system in general, which is why it's been around so long. But Open OnDemand really makes that learning curve, more of a curve instead of a brick wall. So we'll talk about that today. We'll talk about software on HCC. So, the cluster is great, but unless you can use it for what you want, it's basically a big paperweight. So being able to use software is very important. We'll talk about how HCC and HPC clusters in general manage software packages using what's called module. So because there are a jillion and one software packages, we actually need software to manage our software, if that makes sense. So we'll talk about how module is used to load and unload various packages. And I should mention that, what we're doing here at HCC is pretty much standard practice across the board. So if you learn things here at HCC and then you go to a national level resource or another university, the environment should seem fairly familiar. We try to follow industry practices as best as we can. Then we'll talk about Conda, the Conda Package Manager. We'll go over how to create and manage these custom Conda environments. And how to use a custom Conda environment in Jupyter, which I think I have double there in the bullet points. Sorry about that. But the idea there is you can create a Conda environment, and then you can use that in the Jupyter notebook. And that's a very powerful tool because you can customize whatever you need in your environment and then use it through the Jupyter notebook interface. Oops. So moving right along, Open OnDemand. What is it? It's a GUI platform. It's a portal, really, which provides web-based access for high-performance cluster resources, high-performance computing resources. It's developed at the Ohio Supercomputer and funded by the NSF. So it's an NSF-funded project. It's not going away anytime soon, thankfully. And really, the goal is, again, like I mentioned, to ease access onto these HPC resources to make it less of a brick wall and more of a smooth process. Why is it useful? Well, again, we can do a lot of things through it that are easier to do for folks that haven't been familiar with the command line environment before. File access, you can view, upload, download, edit files. You can control your jobs. It has a built-in terminal, which is nice. So if you need to go to the terminal to do stuff, you can do that from right within the same interface. You don't have to have a separate terminal window open. It provides access to various applications. So mentioned here, the desktop, which gives you essentially a full Linux desktop running in your browser on the resource, which is great. Jupyter Notebook, and then we also have several single purpose applications, MATLAB, Mathematica, a few other things that are part of Open OnDemand. There's no install. It's a browser. As long as you got a browser that's relatively modern, you're good to go. And it provides a nice GUI interface. So to connect to Open OnDemand, we have interfaces for both Swan and Crane. So it's just swan-od.unl.edu, which is what we'll be using today. And for Crane, it's just crane-od.unl.edu. So again, let me see if I can swap over in a second here. So when you hit that page, it's going to ask you for your HCC credentials. So you just log in with your HCC username and password as you would anything else. And then, of course, we do our favorite duo dance there. And after you log in, it's going to present you with this dashboard, which is really where you want to start from, where you will start from, excuse me. And you can get back to that at any time by clicking in the upper left-hand corner. So these screenshots here say Crane. We're going to be using Swan today. So it's a little, apologies for not having the screenshots quite updated, but it's the same thing. It'll just say Swan instead of Crane. You can, it has a little help menu where you can do things like contact support, get a hold of the documentation. It has a file manager, so it has the home, your work, and your common directories available. So it makes that easy to upload and download files there. This is just a preview of the interface, and we'll do a little bit of this stuff live here in a second. So it's not going to just be PowerPoint all the way. You can edit files, which is really nice. So it has a built-in editor. That's really handy. You don't have to upload and download things back and forth to edit anymore. You can go to other directories. So you have, if you have a specific directory you want to go to, you can do that as long as you know the path. Upload, again, you can, it'll just pop up a file chooser like you would normally see on any other website, and you can choose files. You can download files. It has job submission control, which is really nice. So under the jobs menu, it has two headings basically. So active jobs and a job composer. So the active jobs will basically give you a snapshot of what jobs you have running at that time. So you can see that it has the job ID, it has the name, it has the status, which is really, really handy. Completed or running. It's all color coded for easy viewing there at a glance. The job composer is really nice. So this will basically hold your hand a little bit as you create and submit jobs. So submitting jobs for the first time can be a little imposing because it's essentially just a text file that you have to put together. We of course try to provide as many examples as we can, but that first time it's always a little imposing. So this will sort of hold your hand as you go through. So we have templates, pre-made templates for various things, popular things, Blast, Mathematica, those type of things. And so it will walk you through how to create those and submit them. So it has basically, fields that you would fill in appropriate to what you're doing, and then you click create new job, and it will create that job template for you. It also has a built-in shell, which again is really handy. So if you need to drop down to the shell to do something that's not necessarily possible through the GUI itself, you can do that right in your browser. We also have the various apps. So the virtual desktop and the Jupyter Notebook are two of the most popular, but we have others. So the virtual desktop will again give you a full Linux desktop right in your browser running on the resource, and Jupyter is the Jupyter Notebook resource or the Jupyter Lab resource now. Submission is simple. It's basically just a form you fill out, various parameters, how much time you want, how much RAM, that kind of thing, and you click launch. So here's a screenshot of the desktop. So this is what it looks like for MATLAB anyway. So you get access to the full MATLAB GUI. And then here's a screenshot of what the Jupyter Lab interface looks like. So we provide various pre-made kernels. So we have kernels for all the popular things, the various Python versions, TensorFlow, R, that kind of thing. So once it runs, you just click launch desktop, and away you go. Okay, so let's swap over here, and we'll do a bit of a live demo, and folks can hopefully follow along with me here today. Let me see if I can stop sharing this. Anyone have any questions while I'm doing the Zoom screen sharing dance here? Have folks used Open On-Demand before? Do you find it useful? Is there anything about it that you would like changed or improved, or any pain points that you run across? Okay. So hopefully folks can kind of follow along with me today. First of all, has everyone been able to get logged into Swan's Open On-Demand? If you've been able to do that, please put up your green yes. If you're having issues, put up the red no, and someone will virtually come up beside you and help. Give folks just a couple of minutes to make sure we get all logged in here, and then we'll do a little bit of live work. Colin, what time's our first break scheduled, so I know where I'm at?
Whenever you'd like.
Okay, we don't have, okay, perfect. Anyone having issues getting logged in? Again, if you've logged in, please put up that green yes, or put up the red no if you're having issues. Okay, let's forge ahead. So as I mentioned, this is the home interface, or the home page, the landing page for Open On-Demand. So you see up here across the top, we have our menu. So we have our files section, which will open the various directories. So it pre-populates your three main directories that you get on HCC resources. So your home directory, your work directory, and your common directory. Next, we have the jobs bit. So it has either the active jobs list or the job composer. Under the clusters, it's a little bit hidden there, but under clusters is really where the shell access is. So if you click that, it will open a new window that has the shell. So this is the same thing that you would see as if you were logging in directly with an SSH client. So again, that can be handy, so you don't have to swap back and forth between Open on Demand and another program to do anything with the shell. The interactive apps, that's really where the rubber hits the road there. So if we do interactive sessions, so these have already been completed, so I'm just gonna delete those off of there. So on the left-hand side here is where we have the apps that we provide. So for example, the desktop, this is the interactive desktop. We have various GUI apps that we provide. Some of these are commercial, so you do have to have access to a license for them, but some of them are either free or they're covered by a university site license. So for example, Mathematica and MATLAB are both covered by the site license. So you should have access to those directly. We have a few things down here that are classified as servers. So if you want to do RStudio, this will launch an RStudio server, and you'll have access to the RStudio web interface. And then probably Jupyter Labs is the most popular thing here. So let's go ahead just for fun and launch a desktop. Hopefully everyone can follow along with me. So again, this is the launch form. So basically what it's going to ask you to do is fill in values for the normal things that you would have to request for a cluster job. So number of cores, running time, amount of RAM, where you want to actually submit it in terms of which queue or partition, and any special reservations that you might have access to. So I'm going to bump this down a little bit. We only need 2 cores really here. Let's do 1 hour. And 4 gigs is fine. So for today, we have a special reservation, this JWS 2022, which will make sure that your jobs start pretty fast. Normally, you wouldn't have this, so you would normally just leave this field blank unless you have access to a reservation, either for another workshop or perhaps through your lab or something that has purchased some type of priority access with us. You can actually have it email you when it starts, although generally speaking, it starts pretty fast, but that's always an option if you want email. You can actually request GPU resources through this. So if you want a virtual desktop with a GPU, you can do that. It tells you here, you fill in the GPU partition and specify GPU for the GRESS field, just like you would for a batch job. And so then we just click launch. And again, this can take a few minutes. It shouldn't take too long since we have the reservation. So if anyone, go ahead and do this if you would please, and put up your green yes if you get to this place and everything looks okay, and again put up the red no if you're having issues. So then once it starts, so there's a couple of sliders here that can be kind of important. So there's compression and image quality. So this really depends on the speed of your connection. So if you're on a fast connection, you probably want to have compression toward the left or toward the off, and you want to have the image quality toward the right for the high. So the way I have it here is no compression and high image quality, which is fine if you're on a fast connection, which I am. If you're doing this from a flaky Starbucks connection outside, while you're sipping your coffee, you might want to play with these sliders a little bit to try and bump down the image quality and increase the compression to minimize the amount of data traffic. So then we just click launch, and it opens a new window. Hopefully everyone can see this. Again, if you're having issues, put up your red or ping one of our staff folks here. And so this is basically an XFCE desktop. So XFCE is a window manager for Linux. There's a million and one of these things, but we chose XFCE because it's pretty lightweight, but it's pretty user-friendly as well. So across the bottom here, it has some frequently used items. So it has a terminal, so you can just click open a terminal. And again, this is so we're running on a compute node in Swan, right? So this is a job inside of Swan. So you can do things interactively in here like you would on your own desktop, but it's running inside a Slurm job. So you're not stepping on anybody else's toes by doing stuff on the login node or something. It has a file manager, so you can just drag and drop things around like you would normally be used to. It has a web browser. I think it's Firefox here. So if you want to do things on the web while you're doing stuff, you certainly can. You can see it's relatively snappy, right? I mean, I can click around, and there's maybe just a little bit of lag, but again, as long as you're on a pretty fast connection, it's very usable. Sometimes these GUI things can be so laggy that it's borderline unusable, but this is actually pretty good. We have a few applications built in, so you can scroll through here, but Firefox and a terminal are probably what you'll need most of the time. I think it has a little text editor built in here somewhere, if I can find it. Yeah, Genie is a little text editor, so you can essentially sort of a Linux equivalent of Notepad or WordPad. So you can use a GUI text editor if you want, of course, and then anything in the terminal, right? So you can use Vim or Nano or whatever you're comfortable with. Did everyone get their desktop to launch successfully? Let's take a couple minutes here and make sure folks are good. Again, please do the green yes if you're good to go, and if you're having issues, do the red no, so we know you're having issues, and we'll try to help you out as best we can. Again, any questions on this while we have a minute here? Again, don't be afraid to talk. We'll edit all this out in the recordings we post, so your anonymity is guaranteed. But it'd be really great if we could have more of a conversation today with this session. At some point, I will get hoarse if I talk only myself all this time. So. Okay, give folks just a couple seconds here, or a couple minutes here to get caught up, and then we'll do a Jupyter Notebook demo. Okay, hopefully everyone's good to go with the desktop here. So again, in this terminal, you can do anything you would normally do. That includes loading modules, which we'll talk about here in a second. But for example, you can see that it has the default Swan modules loaded. So if you want to use those or do anything else, you can certainly do that from within this desktop environment. So to exit out of here, we'll just go ahead and close all of our things. And then in the upper right corner, there's this log out option. So you just click that, and you can check or uncheck that as you want. Doesn't really do anything. And then just click log out, and this will disconnect. And then in a few seconds, this will change to be an active session to a past session here. Yep, there we go. So these what they call cards, they'll stay here for a while for debugging purposes. If you're bothered by them, you can click delete. But basically what happens is each job has its own unique session directory. So this big honking UUID here. So if you click on that in a new tab, it will open it in the file browser, and here's the various files that are relevant for that session. But the most relevant thing here is this output.log. So if you're doing something and there's crashes or something isn't working, this output.log is a good file to look at because it will likely have error messages related to what's going on. So just a good little side note there. So let's do some Jupyter Lab fun. So we click Jupyter Lab. So you can choose a working directory. So if you don't choose anything, it will default to home. But if you have a particular directory you want to use, you can either type it here, or you can use the little file browser widgety-doo to find it. So for example, let's say we want to do job examples. So I do that, and then I just hit select, and it automatically puts that in there. Same thing as before: number of cores, how long, RAM, partition selection. And in this case, we're going to use our JWS 2022 reservation again. So we click that, and we click launch. And again, your waiting time shouldn't be terribly long. Mostly depend on how much, what level of resource you're asked for. So again, as a general rule, longer time, more CPU, more RAM will result in longer waiting time. But again, it shouldn't be, we strive to have these things start in, 5 or 10 minutes or less. So if you're having longer waiting times than that, certainly anything over a half hour, contact us and let us know, because there might be an issue. We want these to be interactive, and that doesn't mean, sitting there for an hour waiting for the thing to start, right? So then we just do the same thing. We connect. There for the Jupyter sessions, there's no sliders because it's just a web page. So then it opens the Jupyter Lab interface. If you've used Jupyter Lab before, this should look very familiar. HCC provides pre-canned kernels for a lot of things. So for example, MATLAB, Octave, the various Python versions, TensorFlow. If you see, if there's something that you would like, you can certainly request that from us, and we'll do our best to provide it. Certainly if it's something that's fairly widely used within a community that you think would benefit others, then you let us know, and we're certainly willing to try and install it. We'll talk about later here about using custom Anaconda environments. So if you need something that's pretty custom, that's not typically something we would install system wide, because it will probably only be applicable to you or a small number of people. But you can certainly do that in your own home directory and make that available in Jupyter Lab, just like these kernels are here. So let's just pick one, Python 3.8. Again, if you've used Jupyter, nothing here is terribly surprising. But if you've not seen it before, it's good to do a little bit of examples. So this is basically Python code, right? So I can do any kind of standard Python. I don't know what is version of thing. Yes, it is. Okay. So standard Python, standard Jupyter notebook, nothing surprising here. We do have a few extra additions built in. So we have a get functionality. Oops. See what else we have here. We have some extensions built in. Yeah. So these are the extensions we provide. If you want to do your own extensions, we're working on that. Jupyter only added that functionality in the 3X series, and it requires some configuration to make that work. So we don't quite support it yet, but we're hoping to do that next time we upgrade Jupyter Lab itself, is to add support for user installed extensions, because I know there's quite a few things that can be useful if you can do extensions. So that's Jupyter. Any questions on this? Everybody get here okay? If you have any issues again, please put up your red X no thing. Okay. Again, if you, so we also have a few things down here. So you can actually get a terminal within Jupyter, right? We have a few other things for dealing with text files and markdown and things. So again, if you know of a kernel that would be widely used that's not here, please let us know, and we'll do our best to make that available system wide. So to quit Jupyter, you just go to File, shut down. It automatically closes the tab or the window, and then again this will swap over to the past job card. Okay. So that's the review or the refresher for Open OnDemand. Any questions about Open OnDemand before we move on to the next part of the lesson today? Feel free to put stuff in chat too if you prefer to do that, and I'll try to answer as best I can. Okay, let me swap back over to the PowerPoint. Yes, I think so. Okay. Oops, sorry, give me 1 sec here. Lost my chat window. Okay. So let's move on to running applications. So all applications installed in HCC clusters are loaded in individual modules, and I caveated that with, well, almost all, because we do provide some things through Singularity, which is a container software. So if you're familiar with Docker or Shifter or those type of things, Singularity is container software designed for HPC use. So we do provide some things through it because it offers some advantages over local install in some cases. The number of things is relatively small compared to what we provide via module. So module is the 90+% of things, but there are some things that are provided via Singularity. So if you aren't seeing something that's in a module, it's possible that it's there in an image, in which case feel free to just drop us an email and we can follow with you on that. We're not going to talk about Singularity here today very much, but I just wanted to mention it so that you know that it exists. So what are modules? Basically, it's ways of conveniently changing the user environment. So it does things like it changes the path variable or the LD library path variable. If you don't know what those are, it's fine. If you do know what those are, it's just a little bit of a peek behind the scenes of what module actually does. But basically all you have to know is that it changes your environment to make the program that you want available. And conversely, when you unload or remove a module, it reverses those changes. It has a hierarchical structure. So if module A is dependent on module B, then module B must be loaded first to load module A, and there are reasons for that. So the hierarchical bit is the thing that I think people find the most confusing, because depending on which command you run, it might not always be immediately obvious what modules are available, and so we'll talk about that here in a little bit. They typically follows the naming convention of software name / version. So for example, Python 2.7, the module name will be Python /2.7. Hopefully that's fairly straightforward. One little side note that HCC does is we typically tend to drop. So if you're familiar at all with software versioning, you know, most of them follow the x.y.z scheme, right? For the module names, HCC will typically drop the Z just because it's less cluttered and it allows us to do some updates behind the scenes without you having to change the module name. So you know, that way it doesn't break things in your scripts and whatnot. So this is all controlled by a command literally named module. So let me switch over to my terminal here, and we'll do a bit of an exercise. So is everyone able to get a terminal either through Open On-Demand or directly in via SSH? Let's take a couple minutes and make sure everyone's up to speed with that. If you're good to go, please put up your green yes, and if you're having issues, put up the red no, and someone will help you. So if you're in Open On-Demand, you can do again the cluster shell access bit to get it open, or if you want to, you can SSH directly in with the terminal app. So it's up to you, whichever you find more convenient. So let's take 2 or 3 minutes here, make sure everybody's up to speed, and then we'll press forward. Okay, hope everyone's good to go. Again, if you're having issues, post in the chat or put up that red X, and we'll help you along. So before we move on to the terminal examples, do a little bit of a sidebar here, and you know, what if I want to use something else that's not there as a module already? So there's a few there's a few options, excuse me. So one of those is, and probably the hardest, certainly, is building the thing yourself. So you're certainly allowed and encouraged to install your own software in your home directories, essentially, if you would like to. If that's something you're comfortable with, then by all means, knock yourself out. And just be aware that it can be kind of a time-consuming process at things. So it depends on the complexity of the software and how many requirements it has and things like that. Some things take 30 seconds, and some things can literally take weeks to build all of the required dependencies and whatnot. So again, just keep that in mind, but you're certainly welcome to do that. Another option is to create Anaconda environments. And then that's what we're going to talk about here in later today. That's probably the most straightforward way to get things installed for you, is to create your own Anaconda environments. There's also the Docker Singularity option, which I alluded to a little bit ago. So the Singularity software can run Docker images directly from Docker Hub. Generally speaking, those will work as is. There's a little bit of caveats for, you know, things like if you want to run a MySQL server or a web server or something like that, that might not work as you would expect it to on the cluster using Singularity. But certainly, if it's a simple Docker image that just has, you know, a single application in it, you should be able to just run that directly from Docker Hub using Singularity. So, instead of Docker run, it's Singularity run or whatever. You can certainly create your own Docker images. So if you're comfortable doing that, that's certainly an option. Create your own images, upload them to Docker Hub, and then run them using Singularity on the cluster directly. Again, there's some caveats with that, but generally speaking, for sort of simple things, that should just work. In air quotes. If you have questions about that, again, we're certainly happy to help answer those questions as best we can. And the final option is we can install it for you. So we have a software install request form. So just fill that out and give us the details on that. And we're certainly happy to look into that for you. Again, as I mentioned before, the installing software can either be 30 seconds or it can be 2 weeks or even longer. So please keep that in mind when you request a software installation. We do those as a best effort thing. So if it's a very complicated thing, or if there are other things going on that, like we're doing workshops that week or something, that can add to the time that it takes to get that done. So the best thing there I can recommend is do that request ahead of time as much as possible. So, I mean, we understand that sometimes you literally don't know that you need something until you need it. But if you know that you're going to be starting with something in a few weeks and you need this particular bit of software, please try to request that earlier rather than later. And that gives us time to look at it, and that means that you're not waiting on it, while we install it. So everybody benefits in that case. So module commands. So module has probably a dozen or maybe even more commands, but you really only need to know a few to get things done. So for example, the module avail command will list what modules are available to be loaded. And the keyword there is available. So again, I mentioned that module is hierarchical. So module avail will only print what's available based on your current modules that you already have loaded. So that's the thing. I think that's probably the number one thing that trips people up, is they run module avail. They don't see the module in the list, and therefore they think it's not available. But that's not necessarily true. It could just be that you don't have the proper prerequisites loaded to see it. So the answer to that is the spider command. So spider, you can think of that as a search command. To be honest, I don't know why he didn't just name it search, but whatever. So module spider is, like I said, that's a search command. So if you're looking for something, I would start with spider. And the nice thing about spider is it will tell you that if you don't have the prerequisites loaded, it will tell you what prerequisites to load for that particular module. So it will help you load what you need to in order to load the module that you want. So the two main commands then are module load and module unload, and it does what it sounds like. So it will either load or unload a module. So module load Python 2.7 does things in the background to make that version of Python available, and module unload Python 2.7 will basically undo those changes. Module purge, that basically unloads all the currently loaded modules. So if you want a completely clean environment, you would run module purge. And module list will list the currently loaded modules. So the module, like most commands, has a help option sort of built in. So if you run module -- help, it will give you the list of commands and some information about those. And here at the bottom, we have a link for the available software for Crane. There's a corresponding page for Swan. So there's two ways to basically check if something is available. Then you can either use the module spider command, or if you prefer, you can check the web page, and it has a table that you can search to find what's available. And the table on the web page will tell you the prerequisites as well, if you need them, if you need to use them. Okay, let's swap over and we'll do some terminal examples here. Any questions on that while I'm swapping around my terminal here? Oops, let's see here. Okay. Can everyone see my terminal? Is the font big enough, or should I make that bigger, Colin?
I may go a smidge bigger, but otherwise it's fine.
Is that okay?
Yep.
Okay, great. So when you log in, we preload a set of modules for you for commonly used things. So after you log in, you can run the module list command, and it will show you what's currently loaded. So this is Swan. So we load a recent version of GCC, which is a compiler. We load a recent version of OpenMPI, which is a multi-node library for using. It's the most popular way to use multiple nodes in a cluster is via MPI programming. We also load Python, Perl, Git, and Nano. So these are commonly used things that we think would benefit everybody to have preloaded. So that's why they're there. So now if I run the module avail command, and again, I hope folks can kind of follow along with me on this and do it real time. If you're having issues again, please put up your red X there. So module avail, it will again tell me what's available to be loaded based on what I currently have loaded. So it's kind of a long list. So you can hit the space bar to scroll through. You can see we have a lot of stuff, right? So this is why we need software to manage all of this stuff. Let me scroll back up here. So core modules, those are modules that are available to be loaded directly. That is, they don't have any prerequisites. So you can see we have a lot of things that are core modules. So for example, a lot of the bioinformatics tools, they aren't dependent on really, a particular compiler or MPI, so they can be loaded directly. Next up, we have compiler dependent modules. So these modules depend on a particular compiler version. So in this example, they depend on GCC 11. So for example, GSL, OpenMPI, those are available only after you have GCC 11 loaded. And the final level is the MPI layer. So these modules depend on both GCC 11 and OpenMPI 4.1. So they're only available to be loaded when you have both of those modules already loaded. So again, this is the bit that tricks people up a lot, is they don't see something in this list, and therefore they assume it's not available when the case could be that you just don't have the right prerequisites loaded. So what happens if I do module purge then? So let's do module purge. So now I run module list again. If you can say, yep, no modules loaded. So now if I run module avail, oops. So the only thing avail lists now are the core modules, right? Because I don't have GCC and I don't have MPI loaded. So if I wanted to load lamps, for example, I can use, so if I try to load lamps right now, right? So I do module load lamps. Nope. So it says I can't do that. And then it even actually suggests to you module spider lamps to see how to load the modules. So if I run module spider lamps, so now it has stuff, right? So in this case, there's only one version of lamps available. So it goes ahead and just prints those prerequisites. But if there was more than one version, basically what it would do is it would prompt you to add the lamps version number. So let's see if I can find an example of that. Let's try VASP. Yeah. So VASP has more than one version available. So in this case, to get more specifics on what the prerequisites are, we have to use the full name, including the version, right? So now if I do module spider VASP 6.3, now it tells me more specifics, and it actually tells me, here's what I need to load. So I need to load the Intel 20 compiler, and I need to load OpenMPI 4.1 before I can load VASP 6.3. Right, and I can actually do that all in one line. I don't need to do different commands. I can do module compiler Intel 20 OpenMPI 4.1, VAS 6.3. Now I will say that the order matters here. So you need to have it, excuse me, you need to have the module names in the correct order. So left to right, compiler, MPI, VASP. So if I do that, oops, gotta have the load command in there. Yep. So basically, whenever module doesn't, just comes back to a terminal and doesn't print anything, that usually means everything's fine. It will print an error if something is not working. So now if I run module list, yep, I can see I have compiler Intel 20 loaded. I have OpenMPI 4.1 loaded, and I have VASP loaded. In the case of VASP, I actually have several other things loaded. These are actually additional dependencies that the VASP module loads automatically for you. So you don't have to go through that entire list and load all those first. It will just load those for you in the background. Okay, so then again, if I want to unload VASP, right, I can just do module unload VASP. And in this case, I don't have to give it the version number because it knows, since it's already loaded, what it is. So then if I do module list, and now I'm back to just the compiler and the OpenMPI. And again, module is smart enough to know that because the VASP module loaded these other modules, to go ahead and unload those modules as well when you unload VASP. So it's very good about returning your environment back to what it was. Okay, let's do some exercises. Let me swap back to my PowerPoint. Okay, so we have a few exercises here. So the first one is to find a list of the available modules. And then second one is to load one or more modules from that list you just found. And then try to unload them. And try to do it two different ways. So what that means is that basically LMOD or module will always, so if you don't give module a version number, it will default to loading the latest version. So in order to load stuff, you can either give it just the name and it will load the latest version, or if you want a particular version that's older, you go ahead and give it the version number. So if I just do module load R, it's going to give me the latest version, which I think is 4.1. But if I do module load R/4.0, then it will give me the particular version I asked for. So the third exercise there is, well, actually is a look up information about the R module, how many different versions are available, load a specific version, and then verify that it is indeed loaded by using the r-version command. And then search for something that you use or you have interest in using in one of your actual analyses. If it's available, then go ahead and try to load it and try running a simple command. So we'll give folks a few minutes to do this. Again, if you're having issues, please put up the red X. In any questions or comments, feel free to just unmute yourself and talk, or go ahead and paste it in the chat if you're more comfortable with that. But let's take a few minutes to do this, and hopefully folks can get a little bit of familiarity with the module system. So I'll mute myself and we'll come back in a few minutes. Oh, looks like we have a question here in the chat. Since old versions of software, i.e. Python 3.1 are not deleted from HCC, is there any advantage to not including version numbers in module load commands and scripts, since it will appear that including version numbers would extend the life of that script? Not sure I 100% understand the question there, but in general, we recommend, yes, including version numbers for a couple of reasons. I mean, the big reason is for consistency, right? So if you just do the name, if we install a new version later, then it's going to change your environment, right? So if you're just doing module load R and we install R 4.2, then the next time your job runs, it's going to use 4.2 instead of 4.1, right? Which is perhaps not the best thing, unless you are aware of that, right? So if you're aware that the software version could potentially change sort of behind the scenes, and there's no particular dependence on the version, so you're doing something simple in a Python script, right? And it doesn't really depend on the version, and you just want to make sure that the thing always works. Then you can just do module load Python. But if you're doing something that has a dependence on a particular Python version, then you probably want to have that in the script. In terms of old versions not deleted, yes, that's true. We would prefer to be able to do that occasionally, but we understand that sometimes that's not always possible. Did that answer your question, Bill? I hope. If not, feel free to message again and I'll try and understand better what you were asking. Okay, thank you. Okay, we'll wait 2 more minutes for folks to finish the exercises. Okay, so we have another question here about how are our packages installed system-wide or in home group user? Both. So we install sort of commonly used things system-wide in the R environments, but you can certainly install packages in your home directory. So R is pretty smart. It understands that there's both system-wide packages that are not writable by you as a user, but it will also install things into your home directory and make those available. So you can do either. We'll talk about, or I'm sorry, we both are done. So for you as a user, you would want to just do the standard install.packages, and R should realize that it needs to create a local library in your home directory. It'll prompt you the first time, I believe. If there's something that would be beneficial for everyone to have. That's system wide. We're happy to look into installing that. You know, we can't install every domain package or every R package in the world in a system wide manner. There's just too many. And you know, you also get into version issues, right? So, you know, do we always install the latest of this, or what if someone needs an older version? And you know, it becomes kind of untenable pretty quick. But you should be able to install most things in your home directory via the install.packages method. There are some caveats to that, which we'll talk about when we get to the Conda bit, and that's where Conda can really come to the rescue and make that a lot more flexible and possible. Okay, I think our 2 minutes have elapsed. Was everyone able to do this? Did anyone have any issues with this? Does module make sense? I mean, again, you don't have to be an expert in it, but you know, you probably want to be able to search, load, unload, those type of basic operations. So let me run through. Okay, no, scratch that. Sorry. Okay, I think we'll go ahead if there's no other questions or issues. I think, oops. Will software? Oh, so another question: will software installed in home directory get deleted in 6 months? No. So the home directories are not purged. The only directories that have the purge policy are work, is the work directories. So the home directories are safe, and we do back those up for disaster recovery. But we always recommend that you have another copy of stuff somewhere. So the short answer is no. If you install something in your home directory, it will be there. You can also install things in common, which I'll talk a little bit about in specifically for Conda, but certainly if it's something large, so your home directories are quoted relatively small, it's 20 gig. So if it's something very large, then you might want to consider installing it in the common directory. So again, the common directories have much larger quotas. It's 30 terabytes. They're not purged, right? So something in common will not be purged, but they're also not backed up. So in terms of software, that's usually not a problem. I mean, you know, if you install it once, you can do it again. So if something happens and it gets deleted, you know, you're not losing precious irreplaceable research data, right? So for large installs, you know, we usually recommend using common, so you're not taking up a good chunk or all of your home directory space with a software install. Okay, I hope that answered your question. Any other questions? Okay, let's go ahead and take a break. We'll do 15 minutes, and then we're right at 2 o'clock. So we'll come back at 2:15, and then we'll proceed ahead with the Conda lessons. Thanks, everybody. See you in a few minutes. Okay, let's get rolling again. Everybody back? If you're back and ready to go, please put up the green yes there, and we'll get rolling again. Okay, great. Had a couple of questions in the chat, so let me cover those first. Module Spider searches modules but does not find AlphaFold since that's a singularity package. Is there a way to search all singularity packages? So currently from the command line, no, because they're separate. They're not really modules, so there's not a straightforward way to search for those from the command line. But we do have a web page. So I believe Natasha posted the link to that web page that lists all of the images that we provide. So that's the best way to check. So what we usually recommend folks do is if you run Module Spider, you don't see it, check the Singularity web page, see if it's there. If it's not, then go ahead and submit a software install request. And that table is, searchable and all that kind of stuff. So hope that answers your question. Another question, I believe that GPU computations are still best performed on Crane due to its wider availability of GPU hardware. Will Swan eventually outpace Crane and GPU hardware? So yes, I'm revealing a little bit about future plans, which are always subject to change, but we are anticipating to migrate the hardware in Crane that is still viable over to Swan, and then decommission the parts of Crane, the original parts of Crane that are quite old at this point. So Crane is made up of a few generations of hardware, at least two. So some of that hardware is still viable. Some of it is past its useful life. So in that migration, the GPU hardware that is in Crane that is still viable will be migrated over to Swan. And so then Swan will have, essentially everything it has now, plus the stuff that Crane has that is still usable. Again, that's a future plan that's subject to change based on things, but certainly we anticipate that's likely to happen at some point in the future. Any other questions? I hope that answered your question. Any other questions before we forge ahead to Conda? Okay. So we are going to use these lessons from software carpentry for the Conda work today. So the link's there in the slide. So hopefully everybody can open that link and have that open. We're going to mostly follow those pages. There'll probably be some deviations here and there, but it's probably good to have that page open kind of in the background for you. Most of what we do will be in the terminal, as interactive work though. Before we get rolling on Conda, let me do a little bit of sidebar. So Conda is great, but especially for some of the older versions, the way it handles packages and dependencies can make creating and dealing with complex environments very slow. So the answer to that was a package or a piece of software called Mamba, which is basically a drop-in replacement for Conda, but it uses a different solving engine, and it can greatly speed up the process of creating or activating updating environments. More recent versions of Conda have gotten better. So the gap is narrower than it once was, but still for large things, especially things that are GPU based, because those tend to be pretty complex and have large packages, we will generally recommend using Mamba over Conda. As I mentioned, it's pretty much a drop-in replacement. So on HCC, we have it available. So instead of module load Anaconda, you do module load Mamba. The Conda activate, deactivate commands, which will make more sense here in a little bit, are still the same with Conda, but basically you just use Mamba for everything else. So instead of Conda create, it's Mamba create, etc. So I just wanted to mention that in case you get to the point where you're doing things and it's very slow using Conda. Again, especially for complex environments, we would recommend that you try out Mamba and to see if that will help resolve the issue. Okay, let me swap over to my web page here, if I can find my silly mouse pointer. Share screen. There we go. Okay, so hopefully everyone can see this web page. Again, you might want to have this open yourself. It'd be a little easier to follow along because I'm going to be kind of switching back and forth here. So, as an introduction, what is Conda? In order to answer that, we have to talk about things that are called packages, or sometimes they're called libraries. Those terms are used sort of interchangeably, but basically software, modern software is divided up into libraries, right? So when you're writing software, the software you write doesn't do absolutely everything that you need it to do, right? So if you're writing, I don't know, a geoscience Python code and you want to interact with netcdf files, you don't write raw Python code to deal with those netcdf files. At least I hope you don't. What you do is you use a library, right? So there's a Python library out there for netcdf. If you're not familiar with netcdf, it's just a data file format with some special attributes. So it's essentially a fancier way of storing data over a text file. But if you're writing code that needs to read or write data from netcdf files, again, you don't write that raw code yourself, right? You use a library. So there's a netcdf library. There's Python netcdf interfaces. So if I need to write a netcdf file, I install that library. I call that library in my code to do the writing or reading or whatever, right? And I move on with life. So there's many advantages to that, right? First of all, it greatly speeds up development time. If you have to do everything yourself in code, you're gonna be writing code until the end of time, right? It also, presumably, those libraries are well tested. There's some caveats to that with some things, but basically the idea is that, if you're using a netcdf library, presumably that library has been developed over time. Many people have used it, many people have seen it. It's basically to be trusted, right? You trust it to essentially do the right thing. Of course, there's always bugs, but generally speaking, in any case, it's going to be a lot better reviewed or trusted than something that you would necessarily write yourself in a day, right? Because you're the only person that sees that code. So this is great, but what it does is it can lead into situations where you have dependencies, right? So now if I want to run my code or distribute my code, I need to also distribute my code, but I also need to somehow provide the netcdf library, right? So you get into the situation of dependencies. So modern software packages will typically have anywhere from 1 to 1 million dependencies that they need in order for the software to work. Okay. And to further complicate the matter, you also have version issues. So, perhaps netcdf changes their format at some point, and the new version of the library isn't compatible with the old version. If your software uses the old version of that format, you can't use the new version of the netcdf library. You have to stick with the older version. So that puts version dependencies or constraints on what you can use, right? So not only do you have to have the netcdf library present to run your code, you have to have the right version of it present, right? And so you can quickly get into situations where these dependencies get more complex than any human can manage, right? Because netcdf also has its dependencies, and so it essentially is a tree, right? And it will get out of control very fast. So the idea here is to not necessarily try to provide all of those dependencies system wide, because that can get into conflicts, right? So if you're working on your laptop if you need NetCDF, yes, you can install NetCDF system wide, and for the one thing that you're working on, it's probably fine. But it gets complex when you're in a multi-user environment, right? So it's not, we can't just yum install or apt install NetCDF on the clusters, because your version, the version you need might be different from the version somebody else needs, and it quickly gets into a mess. So the answer to this is what are called environments. So the idea here is that you can create different self-contained environments that have the dependencies that you need for a particular project. And these are separate, so you can have multiple, more than one of these things coexist side by side. And because they're separate from each other, you don't run into version conflicts. So I can have one environment with the old version of NetCDF. I can have another environment with the new version of NetCDF, and I can use those as I want, and they don't conflict with each other. Okay. So Conda is certainly not the first software package or first software system that has done this or attempted to solve this problem. If you're a Python person, you're probably familiar with virtual envs or VENVs. These are essentially isolated environments for Python. And so if you're just doing pure Python work, those work fine. The reason we might want to use Conda is something I'll talk about here in a few minutes. But before we do, I'll talk a little bit about package management as well. So package management is basically a system that will install, uninstall, and manage installing a package, right? So if you're a Linux person, you're probably familiar with either yum or apt, depending on which version of Linux you use. Python has its own package management system, pip. So the package management is the process that installs the software with the correct versions and also handles the updating of the software. So there's two concepts here. There's environment management, which is in managing those self-contained environments with the various dependencies. And there's package management, which is the process of installing and updating the packages within that environment, given the constraints that you want to satisfy for your particular environment. Why should I use one? Well, because it's the only sane way to do it, in my opinion. Managing things manually, doing manual installs on everything, it's fine for small numbers of, for very simple things, but it quickly gets out of control for anything that's more than moderately complex. As I mentioned, if you typically work on your laptop, you may be familiar with using apt or yum or another package management for system for Mac called Homebrew, something like that. Those typically work okay if you're just working locally on your own laptop, because you only would typically need a simple set of packages, and so the drawback to those things is installing software system wide just doesn't really work either in a multi-user environment or when you get to the point where you're having multiple things that you need to support and different versions, right? So if I install NetCDF system wide, that's the only version I can have, right? I can install one version at a time. I can't have multiple versions side by side necessarily. And anybody else that's using that same system is then stuck with that version that I installed system wide. Right. So there's reasons we can't just install stuff system wide via package management on the cluster, resources like a cluster. So the answer to this, or what tries to be the answer to this, is Conda. Okay. And so there's a little bit of I think confusion, and most of that is the fault of the Conda people, because they chose names that were also similar. So there's a good little graphic here that illustrates the difference. So the inner circle is Conda, which is the package management software, environment management software itself. So that's the command that you run, the Conda command. Then the next circle out is what's called mini Conda, which is basically Conda plus Python plus a handful of base packages. So it's a very small distribution that has just the basic necessities to work. And then on the large circle is Anaconda, which is the whole distribution. So Anaconda is mini Conda, which includes Conda, plus a bunch of packages that they think are useful. So, 150 odds, probably more now, but things like NumPy and SciPy and all the frequently used things. So it can be a little confusing. Conda and Anaconda tend to get used interchangeably, and we do it in our own documentation too. It's not, usually you can figure out what folks mean by context, and it, doesn't really, it's not a huge deal. So you'll figure it out, but just be aware that those terms kind of get used interchangeably sometimes. So Conda basically tries to solve both problems, both the package management problem and the environment management problem at once, and it's targeted for scientists. It's targeted for data science work. So Conda packages are pre-built packages that you can essentially just install, similar to how you would install, a Yum package or an apt package. But it also brings along this concept of environment management. So Conda will create multiple distinct environments, and then within those environments, you can manage dependencies and installs on their own from the other environments. So I can create multiple environments. I can install whatever combination of packages I want inside those environments, and it doesn't interfere with the other environment. And I can easily switch between those two. Right. And so another thing that I think sometimes is a misconception is that Conda is not only for Python. So Conda itself, the package management software, is actually agnostic. So you can install essentially any type of software with Conda. So it came out of Python, but it can handle R packages, it can handle Perl packages, it can handle just random binary packages, so for example, the blast package or something like that. And it does all these things, it's agnostic. So it treats them all the same, although it's a little smart in terms of some of the stuff it does. But one of the things I wanted to convey, because I think it is a source of confusion sometimes, is, Conda is just not for Python, right? And because it's not just focused on supporting a single language, it's very powerful, right? Because the limitation, so most of this, the big software packages have their own package management built in, right? So Python has pip, R has the CRAN stuff, Perl has CPAN, but the limitations with those is that they only deal with packages in that same language, right? So pip only manages Python packages. So the limitation there is one that it's a very common one is, well, what if my Python library depends on an external package that's not Python, right? So for example, the netcdf Python package depends on the netcdf library, which is a C++ compiled library, right? So it's not, you can't install the netcdf C library with pip, but you can with Conda, right? So Conda is very powerful in that regard. So it lets you install packages in any language in the same environment, and it manages them all for you. And that's really a very, very helpful, very great thing. And it can ease a lot of the issues that people run into when you're trying to manage Python packages or R packages that need these external dependencies. Okay. Any questions on what Conda is and why do we care? So before Conda came along, right, if you wanted to have your own netcdf install, your option was essentially to build it yourself, right? Which is certainly doable, but it is quite painful for most folks. So Conda really came along and attempted to solve, and to a large part, I think it does solve that problem. Okay. Any questions? Okay, I'm going to swap over to my terminal. So the next section, we'll go and go to the next section, which is working with environments. So we'll cover the basics of how we deal with these environments. And I'm going to go ahead and switch back over to my terminal, but we'll be mostly following the web page here. So if you want to have that open in another window, that might be handy for you. Let me change my sharing. Okay, can everybody see my terminal okay? Give me a red X if something's not visible for you or working for you. So again, we'll be working in the terminal. You can either use the Open OnDemand terminal if you're already there, or you can use a direct SSH terminal. Again, whichever you're most comfortable with. So when you use Anaconda or Conda locally, you have to install it first, and the install is a pretty straightforward process. But when we're doing it on HCC machines, like everything else, we actually provide that as a module, so you don't have to install it yourself. So what we'll start with, so I have a few modules loaded right now. So generally speaking, when you're dealing with Conda environments, because the idea is to have essentially everything self-contained within that environment, you don't really want to usually have any other modules loaded, because it can have some unintended side effects. There are some cases where that is useful, but generally speaking, we recommend people go ahead and just run module purge to, first of all, unload everything, right? So we have a clean environment, and then we'll go ahead and load the Anaconda module. So module load Anaconda, module list. Yep, shows me I have 4.10 loaded, and just to be sure, on the dash version. So let's go ahead and do that. And once everyone's at that point, go ahead and put up your green check mark, and we'll forge ahead. Make sure everybody's caught up before we move ahead a bit. Again, if you have issues, please put up the red X. Okay, I think most folks are good. So let's create a directory to do all of our shenanigans in. So I would suggest first going just to your home directory, so you can do that with CD and no arguments. That'll take you back to home. The web page actually has you CD to a desktop directory. If you have that directory and you want to use that instead, that's totally fine. But I would most of the time you won't have that directory on at least on one of our machines, at least not to start with. So that your home directory is fine too. So as long as you know where it is, it doesn't really matter where the folder goes. So let's go ahead and make that directory. Oh boy, they chose a long name, didn't they? Introduction to Conda for data and tests. Okay. And then we'll CD into that. And if you haven't learned the tab trick, learn it now. So tab is autocomplete. So if you start typing either a file name or a directory name, and you can type a few characters and hit tab, and if the name is unique, it will autocomplete that for you. And if there's more than one directory or file with that name, it will print those. And basically the more characters you type, at some point it will be unique, and then tab will automatically complete it for you. So because I'm lazy, I use that all the time. So if you hear frantic clicking in the background, that's probably me mashing the tab command, try and get that to autocomplete. So there's nothing in here, it's just a blank directory. So we'll use that to do some of our playing. So what is a Conda environment? At the end of the day, a Conda environment is really just a directory. So it's a directory with some special sauce in it. But from from the Linux point of view or the system point of view, it's just a directory. So there's nothing super special about them. You can create a Conda environment any place. So we'll do that exercise with that later. Conda has a default location that it puts environments in your home directory and in a hidden directory, but you can certainly create a Conda environment anywhere. You can just give it a path and it will create that. So again, they're just directories. The caveat to that is you can't move them around once they're created because of some of the special stuff that Conda does when it creates those directories. So if you create a Conda environment in the wrong place and you want to move it, you can't just move the directory. You have to remove that environment and create it new again in order for it to work properly. So just something to keep in mind. So Conda has sort of a special environment that they call the base environment. So this is the environment that Conda creates when it first installs. So when you're doing it on your laptop, that environment, you can actually go ahead and install packages in that environment because it's writable by you. Although the best practice is to not do that. So basically, once you install Conda, it creates that base environment. You don't really want to install anything else in that base environment. Really, all you want to do would be to update things like Conda itself in that environment. For anything else that you need, go ahead and just create a new environment. If you start installing stuff in your base environment, then things can get pretty messy pretty fast. On HCC machines, because the environment we provide is system wide, it's not writable by regular users anyway. So there's no danger of that. So for example, if I run Conda list right now, it's telling me this is the base environment that it's in, and this is a system-wide path. It's not writable by users. So you really can't shoot yourself in the foot too much on HCC resources, but keep in mind when you're doing it on your laptop that you can, and so always create a new environment. Don't just start installing stuff in the base environment. So how do we create a Conda environment? Well, we use a command called conda create. So we're going to create an environment. So we do conda create. We want to give it a name. So we're going to call it Python 3-env. And then basically whatever else we put after this are a list of packages we're telling Conda we want it to install. So in this case, we're going to do just Python. So this is going to create an environment named Python 3-env, and it's going to put Python and a few other packages that Python needs. So again, remember, it's handling these dependencies for you. So all you have to tell it is, I want Python, and any packages that Python needs, it will automatically pull into this environment for you. One other good practice, though, is to always specify a version number for your packages. So it's similar to LMOD or module in the sense that if you don't give it a version number, it's going to default to the latest. But it's best practice to always go ahead and give it that version number. That cuts down on some of the dependency management time and some other things, and it's also helpful for reproducibility. So again, one of the other big benefits to Conda is which we'll talk about a little bit later, is reproducibility. So I can create an environment, I can know exactly what I put into that environment, and then I can recreate that environment somewhere else exactly as I had it in the first location. So it's very powerful for scientific reproducibility and things like that. So in this case, to tell it a specific version, we just do equals, and then let's do Python 3.8. Okay. Let's go ahead and hit enter. And again, this may take a few minutes to kind of spin through. Hopefully not too long. Okay, there we go. So what is it telling us? So it's telling us that it's going to put the environment into this directory. So by default, Conda puts environments in this hidden .conda directory, and then under envs. it's telling us what is it solving for. What did we tell it we want? In this case, we just told it Python 3.8, and then it's telling us everything that's going to install. So all of these packages are necessary for Python to run in this environment, but we don't have to worry about them because Conda handles it for us, right? So all we do is tell it what we want, and Conda does the magic behind the scenes. So proceed, yes or no, hit yes, and hit enter, and it's going to spin through and create that environment for us. Okay. So it went ahead and created that environment for us. So what if we want to search for packages? So there's a command called Conda search. So if you're not sure if a package is available with Conda, you can use the Conda search command. So there's a lot of things that are available, but not every last thing. So it's a good idea to go ahead and search for something that you're not sure on beforehand. So for example, let's search for scikit. Well, actually, let me make sure that worked for everybody. Did everybody get that environment created okay first? Please put up your green if yes and red if no if you're having issues. Okay, everybody's good to go here. So the search command is very, very useful. So let's run Conda search scikit learn. So if you're not familiar with that package, it's okay. It's a very, very popular Python package. So it's going to search for a bit, and then it's going to print all the versions of scikit learn that are available, and it's probably going to be a pretty long list. So I can also do the same version specifier if I want with the search command. So if I don't give it any version numbers at all, it's going to print everything it finds. All right, so yeah, so there we go. So lots of stuff, right? But I can also give it a version specifier. So let's, for example, say that I only want to find versions of scikit-learn that are greater than version 1 point something. So I can do greater than 1 point that, and hopefully I'm remembering my syntax correctly. We'll know in a second. Hasn't complained so far. Oh, no, it's not going to find it. Okay. Might have to do quotes here. There we go. Okay. So you can use the wild card. So the asterisk or the star is a wild card operator. If you've not seen that before, and because we're doing it in the shell, we want to enclose it in quotes. So this is basically saying, show me every version of scikit-learn that is greater than version 1 point something, right? So everything that's greater than 1.0 point something is shown. So it starts with 1.0.1 and goes up to 1.1.1, which is the latest. Okay. So we can specify multiple packages that we want when we create an environment. So let's do an exercise with that. So we're going to do Conda create. We're going to give it a name of basic, scipy, env. And now we're going to tell it more than one package to install. So we're going to do ipython equals 7.13 matplotlib equals 3.1, NumPy 1.18, oops, 1.8, and SciPy equals 1.4. Oh, oops, sorry. You shouldn't see that. I did this the other day, and so there's an existing environment. Go ahead and just remove that. This may take a little bit because it's a more complex environment. We're giving it multiple packages to install. So it has to go through and figure out, what set of packages satisfies that set of requirements. Any questions or comments while we have a few minutes here while this spins through? So again, this is where using Mamba instead might be beneficial. So if you're creating environments and they seem to be taking a while, then you might want to use Mamba over Conda. And again, especially for GPU-based environments, those tend to be pretty large and pretty complex. We would usually recommend Mamba. Hopefully this won't take more than a minute or two. Does anyone use Conda already? If you're already using Conda, give the thumbs up or whatever in the Zoom reactions there. Curious how many folks have already used it. Looks like there's a question in the chat. There's actually 3 scikit-learn 1.1.1. We specify the version. Which one will we actually use? So yes, there are different versions for different Python versions. So if you look at this long, nasty looking string, you can see that it says Pi 3.9 at the beginning, Pi 3.8, and Pi 3.10. So depending on which version of Python you specify, it will pull in the appropriate version build of scikit-learn. You don't typically have to worry about that. So, all you would do is say, I want scikit-learn 1.1.1, and I want Python 3.9. And again, Conda will take care of that magic and pull in the appropriate version for you. Hope that answered your question. Oh, okay. So you mean Conda create -- name XYZ. So no, in that case, so if you want to use Python 3.9 with scikit-learn 1.1.1, then the command would be this. So you just specify which version of Python, which version of scikit. Right. Okay, great. Is it still spinning for other folks? We might have, these lessons are a little bit outdated at this point, so we might have been giving it kind of a bad version combination too, so. In this case, will Mamba make it faster? Yes. So if you haven't done it already, you can unload Anaconda and load the Mamba module and do it with Mamba. Let me see if I can do that in a new terminal here. We'll do an impromptu speed comparison. Okay. So again, to use Mamba, we do module purge first, and we do module load Mamba. And so I'm going to do Mamba create dash name. What do I call this one? Basic SciPy basic SciPy env, and I'll give it a new name so we don't collide with Mamba. And then I'm going to be lazy and copy and paste some of this stuff. One, right? Yep. Okay. So you can see the output from Mamba looks a little bit different, but it's essentially doing the same thing. Okay, so yes. So you can see that it's already essentially ahead of where Conda is. The other thing that slows it down is the fact that it's doing things in your home directory and in your work directory, which are network directories, so that it's not like a local hard drive. So if you're doing this on your laptop, and especially if you have an SSD or an NVMe, it's going to be quite a bit faster because of the things that Conda does in terms of disk access and things are kind of hard on a network file system, and it likes a lot better to have a local disk to run on. So the other thing that I could have done that might have helped was I could have given it a specific Python version. So essentially, the more specific versions you can add to your create command, it's going to help it resolve those dependencies faster, right? So right now it has to spin through and look at all the Python versions. But if I had said Python, 3.7 or 3.8 or whatever, that would have greatly reduced the amount of work it has to do. So if you're finding that creating these environments, especially for the complex ones, takes a long time, then one of the tricks is to try and be more specific with your package name or package versions and names and things. Okay, so Mamba's done, right? So clearly Mamba wins, at least for this. So did anybody get theirs to complete, or is it still spinning? Okay, let's try and bail out of this. I'm gonna hit Control C. There we go. So if it's still spinning for you, go ahead and hit Control C and see if, yeah, figured. See if it bails out for you. So let's try it one more time, but let's do a little bit simpler and let's give it a Python version. So let's leave IPython 7.3, but let's do SciPy, what did I say? SciPy 1.4. Let's give it a Python version now. Say Python equals 2.8. Let's see how this goes. So again, if you hit Control C, hopefully it should bail out on you, and then you can do this do command. It'll see how that goes. If you have issues with that, please put up your red X and we'll help you. Okay, so that's a lot faster, right? So probably something in there had a combination that Conda didn't like, and Mamba was just better at, but live demos, things happen. But it's a good lesson in troubleshooting, really. I'll up arrow my command here in a second so you can see what it, well, I can just scroll up. So here's the new command. If you want to try that instead, again, if you hit Control C, you should be able to bail out of the initial command. Is everyone able to cancel the command and do a new one okay? If you have issues, please let us know. We need to be able to use these environments here for our next set of lessons, so we really need to have them working. Yep, okay, so it's already done. So again, this is the one that worked. So my guess would be that there's something with that particular combination of version numbers that was really hard for the solver to resolve, which happens occasionally. So, oh, thanks, Mohammed. Mohammed put it in the chat because he's smarter than I am. If you want, you can also use Mamba. So module purge, module load Mamba create. If you want to play with it instead. Again, most everything's a drop-in. The only difference is you still use Conda for the activate command, which we'll do here in a second. Okay, everyone good? Anyone still having issues? Put up the red X dealie if you're having problems. Don't want to leave anyone behind here. Okay, so we've got the environment created. So the next step to use it is doing what they call activate. So basically, what activate does is it's very similar to what module does. Actually, it basically twiddles some environment variables behind the scenes to make the commands in the Conda environment available, and it also runs any activate scripts that the packages have. So a Conda package can actually have scripts that will do things at the time the environment is activated, just set variables or whatever. And so the Conda activate command basically does that. So it prints the commands to use right there at the bottom, which is nice. So we just do Conda activate basic scipy env. So you'll notice that the prompt changed. So now it has basic scipy env in front of the existing prompt. So that lets you know which environment is activated. If you don't like it, some folks don't. It's actually configurable. So there's a configuration option to turn that off. So if you don't like that, you certainly can. So how do we know we're using the Python in that environment? Well, we can use the which command, which basically just prints the full path to a command. So if I do which Python, right? So it's returning the path to the Python that's in my environment. Okay. So if I start Python, then I'm using that Python. So Python 3.8. And I can import NumPy. Let's see if I can remember is it numpy.file or something that will print the actual path to it. Yep. So you can verify that it's using the NumPy in your environment and not one from another location. Okay, let's do a little bit of an exercise. So let me swap back to my other screen here. Okay, so let's do this exercise. Let's create a new environment called machine learning env with Python. Let's say Python 3.8. So we'll mix it up. So we want to specify Python 3.8, but we want the most current versions of IPython, Matplotlib, Pandas, Numba, and scikit-learn. So again, if you don't specify a version number, it will pull in the most recent version. If you specify a version number, it will install what you specify. So let's go ahead and do that as an exercise. Take a couple of minutes here. So you want to do a Conda create with the name machine learning environment, and then we want Python 3.8, but then we want just the most current versions of IPython, Matplotlib, Pandas, Numba, and scikit-learn. So let's take a few minutes to do that. And again, if you have issues, please put up your red X there, and we'll see if we can get you straightened out. So let's take 5 minutes. 5 minutes to do this. We'll be back. Okay, everybody get that to work okay? Let me swap over to my terminal here. Okay, so this is the command I used. So Conda create machine learning env Python equals 3.8, and then just Matplotlib, Pandas, Numba, scikit-learn, and it again did Python 3.8 because that's what we told it. But for the others, it just pulled in the most recent version. So keep in mind that we still have our basic SciPy env activated. So if we want to swap over, it's a good practice to deactivate the current environment first. So there's a couple of ways you can do that. You can run Conda activate with no arguments, or you can run Conda deactivate. I prefer the deactivate because it's more it's clearer to me what's going on than running Conda activate with no arguments, but it's your preference. So we run Conda deactivate, our prompt changes back to what it was before. Now we run Conda activate machine learning env, and the prompt changes again. So we know where we are. Okay. So let's play around. Actually, let's switch back. So let's Conda deactivate again, and then Conda activate basic SciPy ENV. And if we don't recall exactly what we had there in the first place, we can run Conda list, which is a good command to know. So it will list everything that's installed in this environment. Okay, if we want to install additional packages, so we created it in our environment, but that doesn't mean that we can't make changes to it. You can certainly do that. You can add and remove packages to any environment as you want. So go ahead and reactivate that basic SciPy ENV, and let's install the Mamba package. So to do that, we use the Conda install command. So Conda install Mamba. And again, because we're not giving it a version, it's just going to pull the most recent. So it's telling you that it will install Mamba, and it's going to make a few changes. And in particular, it's going to downgrade NumPy. So again, probably Mamba has a version constraint so that it can only, it can't be used with NumPy 1.23 for some reason, but Conda handles all that nonsense for you. So all you do is hit yes. And now if we run Conda list again, yep, we can see that we have Mamba 0.55 installed. Okay. There's a handy option when you're running Conda install. It's --freeze installed. So if you run Conda install -h for help, it gives you all the options that it supports, but this one is particularly handy. It basically tells Conda to not update or change things that are already installed in the environment. So that's subject to what the package needs, of course, but it can sometimes prevent unwanted changes. In some cases, Conda will try to update things automatically in some cases. So it's a good option to know about. If things are particularly sensitive in your environment to dependencies or changes, you might want to add that option to try and minimize those changes if you need to. So where do Conda environments live? Like we said, they're actually in this special, well, it's not really special, it's a hidden folder. It's in your home directory. So if you do ls tilde, which is the shortcut for a home directory location, and then -conda, and then -envs. So that's where it puts them by default. On HCC machines, that's fine for smaller things. But once you get into larger environments, and especially things that are GPU based, because they tend to have pretty large dependencies in terms of size, it might be better to put those in your common directory. So we'll do a couple of examples. First thing we'll do is we'll run. Let's run Conda deactivate here, so we kind of get back to our base. So, like I said, you can put Conda environments anywhere. So we'll do a couple examples. We'll do one where we put it in this current folder. So we're in this Introduction to Data Scientists folder. But then we'll also actually do one where we put it in common, so you can see what that looks like. So the Conda create command is just a little bit different. So instead of doing --name, what we do is --prefix, and that will tell it where to put it in terms of a directory path. So within this introduction to Conda for data scientists folder, we're going to create a folder called env, and that's where we're going to put our Conda environment. So let's do IPython. We'll make this a little shorter so we don't spend so much time with the dependency. So IPython 7.3 and Python equals 3.6. So if you're following along in the web document, I'm just dropping some of those dependencies so it's a little smaller. So let's go ahead and hit enter on that. So one of the things that the lesson suggests is to, create this environment as a subdirectory inside a larger project folder. And that, that can, okay, yes, that can certainly be one approach that works. So, if you have things separated into different folders for projects, you can create your Conda environment in a subdirectory in that project. And so that way everything is sort of self-contained, within the top level folder. There's pluses and minuses to that. If you're doing things with Git, in terms of keeping track of your project with Git, then you have to be sure to exclude that folder so it doesn't get, checked into Git, which would not be good since it's a zillion binary files. The other approach is to just have one top level folder for all of your Conda environments. So it's, you would have all those environments put somewhere else side by side. There's, again, it's whatever you find to be the most convenient. Really all that matters is that, it's an organized way that how it works. So to activate this environment, so the command looks a little bit different, right? So instead of just the name, we actually have to give it a path. So there's a couple of different ways to do this. So I can actually give it the whole path. So I can, I can copy and paste that whole thing, right? And that works. The other way I can do it though is I can give it a relative path. So Conda deactivate. So I can do Conda activate, and then I just do the relative path. So that tells it the folder in the env folder in the current folder, right? And so it does it again. So both ways work. It just depends on what's more convenient. So the one difference you'll notice is that it gives the whole, the big honking path, which can be kind of annoying for you if it's a very long folder name. That can be intrusive to work. So you can actually set a Conda config parameter to change that. So let me first deactivate this. So Conda has a whole lot of configuration values that you can set to tweak its behavior. So you can look those up on the Conda documentation. But in this case, we're going to tell it to use a slightly different format for the prompt. So we're going to tell it to just use essentially the short name instead of the full path. Sure I did that right. And that will set a value in a file in your home directory automatically to do that. So now if I activate it again, yeah, so now it's only doing the very last bit of the name. So that's a handy trick to know. Okay, so we created it. Oops, what did I do there? So we created it in this current Intro to Conda for Data Scientists folder, which lives in your home directory. But let's do an example of creating it in the common folder, because I think that's something that's useful for folks. The other advantage to that is if you're working on both Swan and Crane, then you would only have one environment and you could use it on both clusters. Let's do Conda deactivate. So let's just do the same thing, but let's put it in common instead. So I'm gonna just up arrow a bit here to get back. So now instead of doing /env for the current directory, I'm going to do common. So that $ common in all caps is a shortcut for the location of your common folder. So you can use that instead of having to type out the full path. And then let's do, what do we want to call it? Let's just call it my common env. Let's go ahead and do that. Okay, so it's going to essentially create the same environment, but it's going to put it in the common directory instead. Okay. So again, to activate it, I can use the full path, but I can also use that environment variable as a shortcut. So I can do Conda activate common my common env. Okay, and it do which Python again, and yep, it's using the Python from my common environment. So the one thing to be aware of is when you use common, you do have to add one additional line to your submit scripts to enable access to it. So if one of the helpers could grab that link and post it in the chat, that'd be handy. But basically, it's just one extra line for your submit scripts that you would need to include. The Jupyter Notebook apps and the other apps do that automatically, so you don't have to do that. But for plain batch submissions, there's a licenses equal common line that you need to add. There's technical reasons for that, but it's just something to be aware of. Okay, let's do Conda deactivate. So as I mentioned, Conda can handle more than Python. It can actually do R and Perl and some other things. So one of the things we can do is we can create an R-based environment. So we can do Conda create -- name, and I'll do my R env. And the package naming conventions for Conda packages that are R packages is R dash and then whatever the name is on CRAN, basically. So in this case, and the base level, the base install of R is called R base. So basically, if you're creating an R environment, you would always want to have R base. So I'm going to do R base equals 4.1, which is the the R versions. And I'm going to add the packages R dash tidyverse and R dash sparkly R. So if you're an R person, those two packages should be familiar. At least the tidyverse one is. I know nothing about R, and even I know what that is. So let's try that. Okay, so we can see that it's pulling in our base 4.1.3, and all of these other R packages that it's pulling in are all dependencies of either tidyverse or sparkly R. So it's again doing all that for you. So remember when I said that Conda, because it's package agnostic, it's more powerful, right? So some of these R packages can have other outside dependencies that aren't R packages. So for example, libraries, external libraries, and things like that. So Conda is taking care of pulling in all of those libraries. So for example, the XML2 library, the PNG library, the OpenBlaz library, things that you would, if you're just using the R install.packages method, you would potentially have to install those yourself in some manner. So if you need to create custom R environments or have custom R package sets, we strongly recommend for anything that's more than moderately complicated to use Conda. If you need a handful of R packages and they don't really have any other dependencies, then you can just use the R install.packages method, and that should work for you. And you can use the system-wide R. But if you need really custom sets, we would recommend that you create a Conda environment with as many of the R packages that you need as possible available via Conda. And then if you need other packages that aren't available via Conda, you can certainly use. So one thing I should have mentioned in the beginning is Conda doesn't preclude you from using package managers for particular software. So you can use pip within a Conda environment. You can use the R install.packages method within the Conda environment. You just don't get the benefits of Conda in terms of what it would pull in for the other packages. So, and I think the lessons talk about this a little bit later, but generally speaking, you would want to try to install as much as possible with Conda. And then only things that are not available with Conda, you would fall back to the either pip or cran or whatever to pull them in that way. Give this a couple seconds here to spin through. Okay. So we'll do Conda activate my RENV. And if I do which R, you see, yep, it's pulling in the R from the Conda environment. And you know, I can use this just like I would normally use R, right? I can do an install dot packages if I want. I can install more packages via Conda or whatever. Okay, let's do Conda deactivate. So there's more than one. I mean, so if you don't have an environment activated and you want to list the packages in it, you can certainly do that. So Conda list has a name option. So I can give it my RENV and it will list things in the R environment, in that environment we just created. This works, you know, so the name option is similar to it is for Conda create. So it works if you've created the environment in the default location. If you have the environment somewhere else, then you need to give it the prefix option instead. So for example, that common environment we created, I would do prefix common env, right? So Conda list can work either way. You just got to give it a slightly different option. So what if we want to delete the whole thing? We screwed up. We need to remove it and start over. We can do Conda remove -- name my scipy env and then -- all to remove the whole thing. Oh, was it my or basic? I think it might have been basic. Let me see. Yeah, basic. Sorry. So it's basic scipy env. So we can go ahead and remove it. Why not? We can always make it again later, right? That's the kind of the point. So it will prompt you. And so all good delete command should. And it's gone. Okay. That's really the basics of working with Conda environments. We'll get a little bit more into some of the things like reproducibility and sharing here in a second. Any questions on basic operations, creating environments, installing packages, specifying versions, that kind of thing? I should mention that for Perl packages, the naming convention is similar to R, so it's Perl dash and then the CPAN name. The Perl packages, to be honest, are a little more hit and miss than the R packages. So you might have to fall back to installing more of the Perl packages with CPAN minus or something if you need to, but you certainly can. Questions, problems before we forge ahead to the next section? Let me swap-a-roo my screen here. Okay. So again, that was the bulk of the lesson for Conda. So that should get you, pretty good to go with basic operations, but we'll dive into some of the details a bit more now. So we talk a little bit about what a Conda package is. So at its heart, really, it's basically just an archive, what we call a tarball in Linux land. So it's a tar file with stuff in it. You don't really need to, dig into the package structure. other than to know that it's just a tar file. So if you need to, for example, you probably will never have to, but if you have to copy something around manually or something, you can do that by copying the tar file around. Channels, on the other hand, channels are much more important, much more relevant to you, using it on a daily basis. So channels are essentially collections of packages that someone or some organization has made available. If you're familiar with Yum or apt, the concept of a repo, it's a similar thing. So you can have access to additional packages by searching for them and installing them from more channels. So there are a few channels that are defaults. So the main channel and the R channel, those are basically set up. Although the R channel is kind of getting kind of deprecated at this point. But when you install Conda or Anaconda or Mini Conda to begin with, essentially it's going to have the main or the defaults channel configured for you. There's a channel called Conda Forge, which is a very large organization that builds additional packages for Conda. So there are lots of things available in Conda Forge. The main channel basically are packages provided by Anaconda, the company themselves. The Conda Forge channel, Conda Forge is a community organization. So I've contributed some packages. Some of the other HCC staff have contributed packages, but it's basically a community-led effort to provide additional packages. There's also a channel called BioConda, which again, some of us contribute to, which is basically focused on biological related packages. So again, it's a community effort to package up and provide some of provide bio related packages for Conda. On HCC resources, we set up the BioConda and Conda Forge channels for you automatically, so you don't have to add those. But if you're installing Conda for yourself on your laptop and you want to access those, you would have to add those channels yourself. In terms of installing packages from a specific channel, you can do that in a couple of different ways. So you can either add the channel permanently with the Conda channel add command, which will add it in your config so it's there all the time, or you can specify it with the channel option for Conda install or Conda create, I believe, as well. So for example, if you didn't have Conda Forge already configured, you could install SciPy from that by using this -- channel option, right? There's a concept of channel priority. So you can specify multiple channels and you can give them priority. So in this example, it's doing Conda install SciPy 1.6, but it's giving two channels. It's giving Conda Forge and BioConda. And in this case, the order matters. So the first channel given will have higher priority than the second channel. So just be aware of that. HCC also has our own channel, so we also do set that up for you on HCC machines. We package up a lot of our stuff with Conda for ease of install. Mostly we do things that are either not available on either Conda Forge or BioConda, or packages that need some specific tweak for HCC's environment. You're certainly welcome to use any of those packages, on your laptop. We make that channel public, with just the small caveat that some things may be tweaked specifically for HCC's environment, but it's a great way to be able to recreate what you're doing on HCC at a local on your local machines, because a lot of the things that we provide as module are actually Conda environments behind the scenes. So you can create a Conda environment locally that has the exact same configuration in terms of package versions and such that you are using on HCC resources. So you can, try to guarantee that you're doing reproducible or equivalent work both places. So if your packages, if you don't find packages in any of these channels, you can actually search on anaconda.org. So anaconda.org is provided by the Anaconda company, and it allows anybody to essentially upload their packages. So it's done through channels. So for example, if I do anaconda.org/HCC, so this is our channel, right? So you can see all the packages that we've created. If you go to anaconda.org/CondaForge, you see CondaForge's channel, but you can also search. You can search the whole thing, right? So I don't know, give me a package to search here. Let's try this. If I want to search for tidyverse, right? So I find it on CondaForge, and it basically ranks them by popularity or downloads. So the R-tidyverse package from CondaForge is by far the most popular, followed closely by the R channel. But then it also has other stuff, right? So oddly enough, one of HCC's packages is actually here, but you can see other channels that also provide the tidyverse package. So that's great, and it's also a warning, right? So anybody can create a channel, upload a package, right? There's really not a whole lot of vetting here. So if you're installing something from a channel that you aren't familiar with or that isn't well known, it's a little bit of buyer beware. There's a potential for malicious code. It's not a huge potential, but more likely to happen is the thing just doesn't work, right? So just because you find something on anaconda.org and install it, there's no guarantee that it's going to work unless it comes from one of the organizations that's really well known. So just a little bit of caution and advice there. Certainly there's a lot of folks creating packages that are well done, but because there's no vetting, it's a little bit of buyer beware. I don't know if we need to care too much about the install process. You can look through this chart if you want. Basically, it goes through and pulls in data from any channels you have listed or configured. It goes through and tries to match what you request against what the package or the channels provide. And then it goes through and does the dependency resolution for everything down. So of course, there are certain combinations of packages that just aren't possible, right? So, if a version of library A depends on a older version of library B, and you try to have library A and the new version of library B installed at the same time, that won't work. So it's going to give you an error. So in that case, you have to do a little bit of investigating as a user to try and figure out why there's a conflict. That's one case where actually loosening up the dependency specifications can help. So you can remove some of the version specifiers and let Conda try and do the resolution itself. And if there's another configuration of versions that will work, it will typically find that for you. There's an alternate syntax for installing packages from specific channels. So instead of the -- channel option, you can do this double double syntax here, where you can do CondaForge and then TensorFlow, right? Full colon TensorFlow. This is a little bit more handy because it lets you do it on a per package basis. So when you give it the channel option, any package that's present in a channel that's a higher priority is going to be pulled in from that channel. But you might run into a case where, package A is available in CondaForge, but you also want package B, which is available in both CondaForge and defaults, but you want the defaults version. You don't want the CondaForge version. So if you just do -- channel, it's going to pull both A and B from CondaForge. But this syntax lets you say, I only want package A coming from CondaForge. Everything else come from the from my default channel configuration. So getting into the weeds a little bit here, but sometimes you can get some unexpected behavior with the channel priorities. What's much more probably relevant is you find out that there isn't a package in Conda anywhere. So in that case, we talked about a little bit before, there's nothing stopping you from using pip or the R package install or the cpan minus commands in Perl. You can certainly still do that within your Conda environments, but again, you lose the Conda functionality of pulling in and managing external dependencies. So what we recommend and what this document, this lesson recommends is try Conda first and only use pip or R when necessary, right? Another trick that you can do is if your Python package is only available via pip, but also has external dependencies. If those external dependencies are available with Conda, you can also install those dependencies using Conda and then install the package using pip, and it will hopefully work for you that way. So you don't have to necessarily do a manual install of packages. So for Python, there's a great many packages available in Conda now. It's pretty rare nowadays that we run across something that's not in Conda. And what HCC tries to do is whenever we run across a package like that, we do try to put it in our channel so that it's available via Conda, at least on HCC machines. Okay, that was a lot of talking from me and not a lot of typing, so I apologize for that. Any questions on channels? Again, on HCC machines, we set up our HCC channel, the Conda Forge channel, and the BioConda channel with the proper priority order. So things should mostly just work for you. But if you're doing it locally, you may have to set those up. And BioConda has instructions on how to do that. So it's basically a handful of Conda config commands to run to set up those channels permanently. Okay, let's move on to sharing environments. This can be a very, really useful tool. So as I mentioned, one of the big benefits of Conda is reproducibility, right? So I can create an environment and then essentially save that environment configuration and recreate it somewhere else, or I can share it, right? So if I want someone to be able to recreate my work in a publication, I can share a Conda environment file that will let them do that, right? So the way that is managed is with what's called an environment file. So basically, Conda can create a file for you that has the list of things that are in your environment that then can be used somewhere else to recreate that environment. So let me swap back to my terminal here, and hopefully you guys can follow along so it's a little more interactive. Okay. Let's see. Environments do I have to play with here? Oops. Okay, let's do stuff with the machine learning environment. So first thing I'm going to do, I'm going to activate my machine learning ENV again. Okay. So actually, why don't we take a quick break? I think we're due for another break. Let's just take a short, I don't know, 6-minute break, and then we'll come back at 4:05 and finish up. Yep, let's do that. We'll see you back here in a couple minutes. Thanks. Okay. Let's get back to it. So I have activated the machine learning ENV. So then I can run a command called Conda ENV export. Give it the name. And what it's going to do is it's going to dump a summary of basically that environment. So by default, it will dump it to the screen, which maybe isn't the most useful, but you can also give it a file option. So I can say file, and by default, it expects the file to essentially be called environment.yaml or YML. So now if I look, it's created that file in the directory. If I look at it, basically it's a summary of the environment with everything it needs to recreate it, right? So it's got the name, it's got the channels that it was configured with, and most importantly, it's got basically all the packages with their exact versions and builds. So for example, font config 214.0, and then this funny looking H8 yada yada yada, which is the particular build of the package that's installed. So it's everything Conda needs to essentially recreate this environment somewhere else, right? So let's try that. So let's create our own environment file. So let's create a new directory to work in. Let's call it env test. We're going to cd into the env test, and then let's create a file with the following contents in it. So the exercise I'm looking at is in the documentation. So if you go back to that page, you should see a list of dependencies. So I'm just going to copy and paste that into a new file that I'm going to call environment.yaml. You can use Nano, or you can use Vim, or you can use whatever text editor you're most comfortable with. You can do it via Open on Demand. You can create it that way. So I'm just going to do that. And I'm going to save that file. I'll give folks a couple minutes to do that. Let me know if you have any trouble creating that file with the contents. And basically what we're going to do is we're going to create an environment based on that file. Okay, so Conda env create -- file environment.yaml. And it's going to put it in that default Conda environment location, which is in that .conda directory in your home directory. If you want, you can specify a custom location, again, through the use of the prefix argument. Hopefully this is relatively quick. Okay, now we're chugging along. So creating an environment file, by hand is one way to do it, and that's fine if it's a relatively simple set of packages. But more commonly, probably what will happen is you will have an existing environment that you want to recreate. So then you would use that export command, save that to a file, right? So it saves it, it creates the environment.yaml file for you. Then you can take that file somewhere else and recreate the environment using this command. So there's a few different ways to do it, just whatever fits your workflow. As we saw here, it puts channels in the file. So if you have custom channels, those should be included, or you can include them if you make the file manually, depending on how you do it. But the idea is that you can then share this relatively small, simple text file, and someone can recreate your environment exactly on their machine. Okay, so it created our environment for us like we expected. You can also update an environment file or update an environment. So if you make changes to your environment, you can run this conda env update command, and it will recreate the environment YAML file for you. You can give it this -- prune option to remove things that are no longer necessary, so it can clean it up. There's a force option. So if you have an existing environment but you want to recreate it from scratch using the environment file, you give it the -- force option to conda env create. So this env create, is analogous to the plain conda create, just using a environment file as a source. You can also do pip packages. So in the syntax, actually, let me switch back to my browser so it's not. There we go. Okay. So you can use pip in the environment file. So the way you do that is, you would include pip in the dependencies, and then you have this -pip, and then you give it essentially a sub list of pip packages. The one gotcha here is that pip syntax is double equal signs for the package versions, whereas conda syntax is single equal signs. So remember to do double equal here in that pip section if you're doing that. I think that's a good. Oh, so I did want to mention one other thing that the lesson doesn't cover, but it's good to know about. So I wanted to list it, talk about it. So there's something called Anaconda Project, which is it's created by the same people that wrote Anaconda itself. And so basically it takes the concept of the environment file sort of to the next level. So instead of just a simple environment file, it lets you distribute and create essentially project directories. So you can include other things. So at the heart of it, it's a conda environment. So it's reproduces that environment. but it also allows you to include things like data files or other information. And then you can essentially just tar that whole Anaconda project directory up, send it somewhere or post it on a website, whatever, and somebody can download it and reproduce your environment. So again, it takes the concept of reproducibility of the Conda environment and it adds some things to it, So for example, prompting the user for passwords or configuration, downloading data files, starting extra processes such as a database server. So if you need something more than just what a simple Conda environment can offer, you might want to look at this Anaconda project. So HCC actually uses Anaconda project kind of behind the scenes to manage a lot of our Conda environments because of some of the features that offers. So it's a good little thing to know about if you want to do something a little bit more complex than the environment YAML files. Okay. We're gonna do the Jupyter stuff at the very end, but there's one final lesson in this carpentry lesson, which is talking about GPU stuff. So GPU dependencies can sometimes be quite challenging to manage with Conda. It's certainly possible, but it trips a lot of people up. So if you're interested in that, you can read through this. I will say that there's a couple of things that are HCC specific about GPU with Conda. So HCC actually provides a build of the CUDA toolkit that does include the compilers. The version that CondaForge provides do not, but HCC's version does. But generally what we recommend is if you're doing GPU-based stuff with Conda, what we recommend is to do what's called clone, which is basically make a local copy of one of the environments that HCC already provides, and then install any packages, additional packages you need once you've created that clone. And the advantage of that is that HCC takes care of making sure that all the GPU functionality works. So for example, a TensorFlow environment, right? So if you need TensorFlow and you need some custom things that we don't provide in the module that is system-wide, you can actually clone the TensorFlow environment because it's really a Conda environment behind the scenes, and that will get you a working environment with the GPU support working, and then you can go ahead and customize that, using Conda install or whatever for your needs. So just a caveat or some additional details about GPU functionality on HCC resources in particular, because it can be a little finicky to get that stuff to work from scratch. So we recommend, again, starting with an environment that HCC provides and going from there. And we actually have a docs page on that. Applications. Some custom software. Oh, okay. Anaconda. So it's in our Anaconda page. So it's creating custom GPU Anaconda, and this will walk you through the steps to do what is called clone. So Conda Create also has an option where it will essentially just copy an existing environment into your directory. So you then have a local copy of that that's writable, that you can make whatever changes you want to for. So just a couple of heads up on that. So I think then the last thing we'll do today is we'll try to get this thing to work and show the Jupyter notebook connection. I got to get that to work. So that's actually on this same page. So we'll go ahead and just do that with this machine learning environment. So back in the terminal, if you could, I'll switch back to the terminal too, so you can see it. If you could go ahead and make sure that machine learning env is activated, then we'll run these commands there, and then we'll switch back over to Jupyter via Open OnDemand. Okay, everyone see my terminal again? Okay. Okay, so I have the machine learning env activated. which is in my home directory. Yep, so that's fine. So to enable this to be accessed via Jupyter, there's a couple of setup steps. So one thing we have to do is we have to install the IPyKernel package, which may already be installed in this environment. Nope, I don't think it is. Okay, so we'll do Conda install IPyKernel. So go ahead and follow along if you'd like on this. And it's going to pull in some other stuff, which is fine. Okay, so then we have to run one other command, which is to actually install the Jupyter or the IPython kernel, which is really just a text file that connects Jupyter with the Conda environment. So we do that python-m IPyKernel install -user -name. So we're going to use this environment variable, which is which holds the value of the environment name. So in this case, it's going to be set to machine learning env. You can give it custom names if you want. This is just a good starting point. So there's two values. There's the name, which is like the essentially the name of the directory it creates, which you don't really see, and then there's the display name, which is what actually shows up in Jupyter. So you can give that a little bit more of a descriptive name, and if you enclose it in quotes, you can use spaces. So we do Python, and then in this case, we're just going to do the short name or the environment name in parentheses. But you could essentially set that to whatever you want. So, oops, wrong option. Sorry, this should be display name. Trying to type and talk at the same time. So the display name again is what will show up in Jupyter. So you can give that any kind of same name that you want. If you have spaces in it, you'll need to put it in quotes, but otherwise, whatever you think is reasonable. Okay, so it did some magic. So in this case, it installs it in this .local directory, shared Jupyter kernels, machine learning env. So really, it's basically just a text file, or what's called a JSON file. So if you don't really have to know this, but I'll just show you. So what it does is it connects the Python in this environment, in the machine learning env environment with Jupyter. So when Jupyter starts, it will look for these files and hopefully show it. So once everybody's got that Python IPyKernel command installed done, go ahead and put up your green checky mark so we know that you're ready to go, and then we'll swap over to Jupyter. And I should mention that the command is different for different languages. So that command, this python-m IPyKernel command is for Python. There's a different command for R, which you run from within R, but it essentially does the same thing. It generates that little text file that connects your environment with Jupyter. We'll take a couple minutes here and make sure everybody got that to work okay. And please put up your red X if you're having issues. Okay, hopefully everybody got that to work. So let me swap back over to my browser. Okay, so I'm back on Open On Demand here. So I'm going to start up a Jupyter session. Okay, yeah, that's fine. And then connect. Let's see, get back to the launch page. Yeah, okay, there it is. So it's a little hard to see because the name is kind of long. I was going to see if there's a way to make this a list. Maybe not. Anyway, yep, there we go. So if you hover over it, you'll see it. So Python, machine learning, ENV. So we can click on that maybe. Let's see here. New notebook. Oh, I think my browser just died. Something's not happy. Well, I think Chrome probably needs restarted. Okay. Sorry about that. But it's there. So you can use it just like any other kernel. And then, you can continue to customize your Conda environment via Conda install, whatever you need to do, and then use that in Jupyter. So I think that's the end of the lessons for today. Oh, it's not happy. Something's not happy. Okay, well, good timing. Let me switch back over to PowerPoint here. Okay. Yep. So just where to go from here. If you're stuck, let us know. If there's something that our documentation should have that it doesn't, let us know, and we'll try to update that. Documentation is a never-ending task, right? It's never perfect, and there's always more work to be done, but we'll certainly strive to make it better. Most commands, you can use the man command to look for help, or you can use the -- help option. Most Linux commands will support one or the other or both. Of course, Google for this kind of stuff is your friend. Contact us. So we have both remote open office hour sessions. We have those Tuesday, Thursday from 2 to 3. That's information's on the webpage. You can just drop into those. No appointment necessary. That's the point. They're just open office hours. And of course, if you do need another time, if those times just don't work for you, then email us, and we're happy to try and set up another time for that. And then of course our email support is the main avenue for help. So